Uh, all right. So let's talk about the entire system design, right? So now, basically, the teachers interact with the Next.js front-end app. It has query caching. It has the stand for state management. So basically, if you are on home page and if you want to go on to the next assignment page, so when you go back, it should not reload the entire home page again. It should store it as a cache somewhere, right? So that's the stand for you. It helps you reload super fast. So now, the next up thing, the basically the users or the basically are authenticated onto the Express server, right? Right. So now when you upload some sort of a question paper, sorry, like maybe you put up the NCRT physics notebooks PDF, right? It goes onto the Express server, then it goes onto the PDF parser, right? It goes onto the PDF parser and it basically chunks those onto vector embeddings and it's put into embeddings via like OpenAI embeddings, right? And yeah, so now then when you click the prompt that okay, I want to generate this type of question paper and XYZ specifications, then it goes on to the Bull MQ and Redis worker. So basically what this worker is about, this is like the main and the most robust part I've made, right? Okay, before that, the backend is basically made out of Express and TRPCs. It does not use REST API, POST API things. So basically, TRPCs are defined in a single folder, and all the folders, the rest of them are extended from that one file so that every single type of API is validated. It's not REST or POST this method, this method. It's basically TRPC dot maybe TRPC dot get question papers dot user the something like that. All right. Yeah, that's the function call that is being used with the TRPCs, and it gets very easy to validate the entire API structure. All right. Yeah. So you basically put the prompt, then the entire process starts, right? So basically, Bull MQ is a queuing, like a job queuing process, right? Now, but I've backed it up with Redis. So basically, whenever the queuing takes place, the jobs are also stored into Redis. And when it's because it's getting stored into Redis, it's basically a super fast memory, right? Uh, it's basically cache memory and it's super fast. So the Bull MQ can process things very well. It's so basically imagine Bull MQ being processed by super fast job storage. That's the Redis being backed by Bull MQ server. Bull MQ job processing. Okay, sorry, Bull MQ job queuing. Right. So next up, when the moment a single job comes in, it goes on to the processing and it goes on to the job processing. Firstly, that job is processed, right? And whilst that job is being processed, right, the user and the user gets into the same room as the job processor is, and they communicate via WebSocket server. So the teacher is getting real-time updates that okay, you know what, my PDF is being parsed, then my entire these things. A paper has been generated. We are getting doing the vector search and everything that is happening right now and right then, right? Okay. So at the end, vectors, so okay, so via cosine similarity in vector search, the top k, like in this case 10, the top 10 similarity indexes are being retrieved by OpenAI, and it basically generates questions on the basis of that, right? Now, basically, OpenAI generates JSON schema. Does not generate questions. It generates a JSON schema inside of which there are questions. And if OpenAI were to, or maybe the job processor, or were to fail every single time, it basically retries the entire BullMQ server, right? And also, if the OpenAI at the end, like the entire job is finished, right? OpenAI generates the JSON schema. Now, here's where basically the Zod comes in, right? Zod for validation. If the schema is some sort of corrupted, the one generated by OpenAI, Zod validates it entirely, first of all, right? Zod does these two things. If the validation is incorrectly configured, it retries, and the max number of retries is 3. After that it shows generation failed, right? And if right, if the Zod validation basically like it does not fail, it validates completely and your question paper is generated, it saves it onto the assignments and question papers, sorry, Yeah, assignments and question papers, MongoDB Atlas storage, right? Dot basically does not allow you to put garbage inside of assignments that would maybe corrupt your system by later on, since some invalid schema type of files are being uploaded onto the MongoDB Atlas, right? It is a very robust system that allows you to allows the user to validate that okay, my workers are working. The entire like make it very type safe via Zord validations, and it's basically not an API call anymore, right? So basically, when if I didn't put any of this over here, this rediscover, this whole thing could have been simple API calling, right? But the problems with API calling is that it just loads like that. It waits for what, 15 seconds, maybe you can even go to 100 second. After some timeout, it will stop, or you can have it like entirely wait. But if it fails, you will never know. That's the problem with using a simple API call, and that's why we have put up Redis, full MQ backed by Redis storage and also Zord validation, so that we have a completely robust system for generation of question papers and assignments for students. This system would rarely fail in practice, right? Maybe we can shift from MongoDB to Amazon S3 later on, but yeah, this is like the complete whole system design. Thank you so much. In the next video, I will be showing the entire walkthrough and demo of the Veda AI assignment. Thank you so much.